Welcome to SAT Problem Solving. In this video we'll focus on some of the most important percentage problems that have appeared and are likely to appear on the SAT. We'll break down each question step by step, explore the most effective solving strategies to boost your SAT math score. First question. If 20% of 30% of a positive number is equal to 10% of k% of the same number, what is the value of k? To solve this systematically, let the unknown positive number be represented by n. Now we can translate the verbal relationship into an algebraic equation. Next, let's convert these percentages into decimals and fractions to simplify our calculations. Since we are given that n is a positive number, we know it is not 0. Therefore, we can simplify the equation by dividing both sides by n. Let's simplify the multiplication on the left side of the equation. To isolate the term with k, let's divide both sides of the equation by 0.10. Finally, we multiply both sides by 100 to find the value of k. K equals 60. This matches option B. Second question. The price of a book was first increased by 15% and then the new price was decreased by 30%. Which of the following is true about the price after these two changes? To solve this, let's begin by letting B represent the original price of the book. First, a 15% increase on B is represented mathematically by multiplying B by 1 plus 0.15, which simplifies to 1.15 times B. Second, we apply the 30% decrease to this new price. A decrease of 30% on 1.15 B means we multiply that value by 1 minus 0.30, or 0.70. Now we can express the final price after both changes have occurred as B final equals B multiply 1.15 multiply 0.70. Next, we multiply the decimal factors together. To find the net percentage change, we subtract this factor from 1. This result, 0.195, represents a 19.5% decrease from the original price. Therefore, the correct choice is B. The price decreases by 19.5%. This next question asks, if 2a plus 3b is equal to 250% of 6b, what is the value of A over b? To begin, let's translate the percentage expression on the right. 250% of 6b can be represented as 2.5 times 6b. Multiplying and simplifying the right side expression gives 15b. Now we can set up the main algebraic equation. To isolate 2a, we subtract 3b from both sides. Next, we divide both sides by 2 to solve for a. Finally, we divide both sides by b to find the ratio of A over b. This matches option C. The correct answer is 6. Let's look at a problem involving percent relations. If 25% of m is 50, what is 15% of 2m? First, let's translate the first statement into an algebraic equation. 25% of m is 50 can be written as 0.25 times m equals 50. To solve for m, we divide both sides by 0.25, which equals 200. Next, we calculate the value of 2m, which equals 400. Now we need to find 15% of 2m. We can write this expression as 15% of 2m equals 0.15 times 2m. To evaluate this, we substitute 2m equals 400 into our expression. 0.15 times 400 equals 60. This matches option B. The correct answer is 60. Next, let's look at a problem involving exponential growth. The problem states, the cost of an automobile increases each year by 2.5%, and the cost this year is $20,000. If the cost of the automobile is given by C of n equals 20,000 times x to the power of n, what is the value of x? To solve this, let's recall the standard exponential growth formula. Next, let's identify the parameters from our problem statement. The initial value p is 20,000, and the growth rate r is 2.5%. To work with this growth rate, we convert r to a decimal factor which equals 0.025. Now we can relate our base x from the problem to the growth rate factor in the standard formula, where x equals 1 plus r. Substituting r equals 0.025 to find x, we get x equals 1.025. This corresponds to option B. The correct answer is 1.025. Let's look at a problem involving percent increase. Tom's weekly salary was increased from $500 to $875 this week. By what percent was his salary increased? To find this, let's first recall the formula for percent increase. Percent increase equals the quantity new value minus original value, divided by the original value, multiplied by 100%. Next, let's identify our original and new values, which are 500 and 875 respectively. Now, we calculate the amount of the salary increase by subtracting the original value from the new value, which is 375. Next, we divide this increase by the original value to find the ratio. 375 divided by 500 equals 0.75. Finally, we multiply this ratio by 100 to convert it to a percentage. This corresponds to option B. Tom's weekly salary increased by 75%. In this last problem, let us analyze how percentage changes accumulate, specifically within a geometric context. Consider a circle whose radius is increased by 25%. Our goal is to determine the resulting percentage increase in the circle's overall area. To find the exact change, we begin by representing the original radius of the circle with the variable r. Since the radius is increased by 25%, we can express the new radius by multiplying the original radius by a factor of 1.25. Next, we recall the standard formula for the area of a circle, which is pi times r squared. To find the new area, we substitute our new radius expression into this area formula. Now we simplify the equation by expanding the squared term. Squaring 1.25 gives us 1.5625. Therefore, the new area can be written as 1.5625 times pi r squared. By comparing this result to our original area formula, we can isolate the net change. Subtracting the original base value of 1 from our multiplier leaves us with a decimal increase of 0.5625. Converting this decimal back to a percentage shows a net increase of 56.25%. This matches option C. To conclude, we review essential percent strategies for the SAT. Percent questions appear frequently on the test, and having a systematic approach can help you solve them both quickly and accurately. First, utilize decimal multipliers instead of multi-step equations. Rather than calculating 15% of a number and then adding or subtracting it, represent a 15% increase directly by multiplying the original value by 1.15. Similarly, a 15% decrease can be represented simply by multiplying by 0.85. Second, learn to translate word problems directly into mathematical expressions. When reading percent questions, you can systematically convert key terms. Treat the word as an equals sign, the word of as multiplication, and the word percent as division by 100. This direct translation provides a clear, reliable path from the text of the problem straight to a solvable equation. Third, remember to compound consecutive percent changes rather than adding them together. If an item increases in value by 20% and then decreases by 10%, the net change is not a simple 10% increase. Instead, multiply the corresponding multipliers. Finally, When dealing with abstract problems that do not specify a starting value, choose 100 as your initial amount. Working with 100 makes calculating subsequent percentage changes straightforward, as any final value translates directly back into a percentage. This simple technique can significantly simplify complex algebraic relationships. By practicing these 4 approaches, you can analyze and solve the percent questions on your exam with greater precision. Good luck on your test.